So let's see what we get through here today, looking at chapter 4, looking at enzymes. Remember, guys, enzymes are proteins, okay? They increase the rate of reaction. That's the big thing about an enzyme. They speed up chemical reactions. They bring the players together faster, and that allows us to get a chemical reaction to occur a hell of a lot faster than if an enzyme wasn't present. Enzymes never lose their shape or their integrity, so they're not changed by the reaction. And that allows them to stay within the system and be used over and over and over again. In terms of the specific word to help increase that rate of reaction, what they really do is lower the amount of energy that we have to put into the system to get it to occur. And we refer to that as the energy of activation. It helps to lower that hill that we have to get over for the reaction to occur. Okay. No enzyme and an enzyme. Okay. Helps to lower that activation energy. And that allows the chemical reaction to occur a hell of a lot faster, so I can get those products over and over and over again. In terms of kind of the biggest effector of it, really heat. Heat increases rates of reactions more so than any other thing. If you heat it too much, what can happen to the protein?
It can denature.
It can degrade.
Yes, sir. Everybody. Beautiful. Denature. Okay. So if it gets too hot, we can denature. Can anybody think of any examples of heating things up in the body?
Like a fever?
Yeah, like a fever, right? Fever could do it. Fever increases rates of reaction. It just gets all these little parts and pieces moving a hell of a lot more. They bounce into each other and we can get a chemical reaction to occur. pH, very similar to heat, would be pH. If we change the pH of the system, either makes it too acidic or too alkaline, we can affect the functionality of that enzyme, of that protein. Okay. So there's usually a little pH window through which these enzymes function properly within. And, whenever you think of enzymes being affected, those are probably the two kind of biggest things. The third one that we'll talk about is going to be substrate. How much substrate, how much stuff do you have? And in terms of importance, how much substrate you have is going to be one of the more important concepts in terms of how things function a lot within the various different systems that we're going to be talking about in the body. Okay. If you saturate the system with too much stuff, you bog down all the receptors, all those proteins. And the amount of chemical reactions can level off and stop. Okay. And we'll see a number of mechanisms in the body where if it's just too much substrate, too much substances, you get a number of chemical reactions that completely stop, become stagnant, or hell, if you look at it in terms of bringing stuff across into a cell to get things to occur inside of a cell, you can bog down the receptors and you can stop chemical reactions from occurring within the cell as well. So there are a number of different things that these concepts will dovetail in through various different things that we're going to be talking about. Remember, we talked about this, I believe, the other day. All of these enzymes have a specific shape. They have a specific region. Okay. That active site, we have a specific shape to bring in specific substances. And by bringing those substances together faster, I increase that rate of reaction. Okay. So there's my enzyme with a specific shaped active site for the substances to bond with. They bind in there, bring them together, and my products form a heck of a lot faster. And as you can see from that picture there, that enzyme is not unchanged. Okay. So we're bringing these pieces together. Okay. Enzyme is not used up. It is not destroyed. It brings those substances together faster.